CBT Nuggets Network Plus series, Common Troubleshooting Issues. Well, this nugget's going to be a continuation of the previous nugget where we broke down the 9 steps or the 9 phases of a troubleshooting methodology. Now, in that nugget, we did talk about some specific issues and some of the things you need to know about as you move through those 9 steps or those 9 phases of the iterative troubleshooting process. But again, this is going to be a combination of an art and a science, and so having a structured methodology is nice, but you really need some specifics. It helps to know going into it what are some of the most common troubleshooting issues that are going to pop up down at the physical layer 1 all the way up to the applications. So we're going to look at some of the most common troubleshooting issues as far as CompTIA is concerned on this Network Plus exam. In this CBT Nugget on common troubleshooting issues, we've got 4 main domains. First of all, we're going to look at physical issues, specifically the OSI layer 1, and logical issues. We'll look at several wireless issues for wireless troubleshooting, and then finally, issues that are escalated. These go beyond the knowledge base of the Network Plus and will most likely be escalated to higher up network professionals, network engineers, escalated issues. The first common critical troubleshooting issue at layer 1 of the physical layer is that of crosstalk, and it's one of the primary reasons why we don't use the category 3 or category 5 cable anymore. As you can see from category 3, the number of twists over these few inches becomes, well, more twisted. And remember, twisted pair is made of insulated copper wires, and they have been twisted around to form the wire pairs, okay? This is 22 or 26 gauge wire typically. Now, because wire carrying electricity transmits and receives electromagnetic energy, nearby pairs of wires that are carrying signals can interfere with each other, and this is called crosstalk. And so this twisting of the pairs is why it helps us to reduce crosstalk and other EMI sources. And the number of twists and the interim spacing is designated by industry standards based on the number of twists per 11 inches. So obviously, since the most common type of cabling is unshielded twisted pair, well, we're more susceptible to crosstalk. That can degrade our entire network. It can force us to have lost data packets. It can affect applications. So one of the things you might want to do is you look at running your cabling up here in the plenum space, or the airspace, with the dropped ceiling or the raised floor, is consider using category 5E or category 6 cable. That could be a mitigation against crosstalk. Also consider possibly implementing fiber, specifically MMF, for your short distances, because fiber is not susceptible to as much interference or crosstalk. Now, one thing about UTP that we're using here is it's cheap, it's inexpensive, it's easy to install, and you can also use crimpers and punch down tools at the patch panel or the 66 or 110 block. We know we get data transfer rates from 1 to gigabit per second. We're also seeing some 10 gigabit specifications. However, it is susceptible to crosstalk and EMI. And the other thing is attenuation. Okay, it actually has what we call rapid attenuation. So your cabling distance is limited to hundreds of meters. Coaxial cable, for example, has moderate to low attenuation. So if you use, let's say, repeaters, you can actually extend the distance to thousands of meters. So to mitigate against the attenuation problem as a troubleshooting solution, you could implement fiber optic cable, for example MMF, and that will give you extremely low attenuation or loss of signal. And you can support distances of up to 2 kilometers. Now, CompTIA wants you to look at the concept of collisions as a physical troubleshooting issue, but the best way to mitigate against Ethernet collisions. And again, we look at the behavior of Ethernet on a bus or in a hub with its carrier sense multiple access collision detection. We know that collisions can occur the more nodes you add. They're all contending for that bandwidth. It's shared Ethernet. But the best way to mitigate against troubleshooting of collisions is to simply do what we've been doing for years, introduce a hub that does switching, a switching hub or a layer 2 switch. This way, each port on the switch is going to be isolated, full duplex isolation from the other ports. And then the backplane of the switch here does this kind of physical bridging between the devices. It takes the incoming packet of data, looks inside of the destination hardware address, and then sends it to the destination port or ports. It doesn't flood the packet out all of the ports like a hub would do. This way, each computer, each laptop can transmit whenever it has to. Now, you will run into situations where you have collisions. Again, if I took this and just simply put a couple of little antennas on it and turned this into a wireless access point, suddenly this becomes RF to these end stations that are now using wireless cards on them. Now we get into the situation where we're in a wireless environment. In that environment, you do have to deal with collisions. We have the RTS, CTS environment and a carrier sense multiple access collision avoidance environment. So this wireless access point becomes basically a shared Ethernet hub. So as you add more laptops and you add more workstations to this wireless area, you will deal with collisions. So we want to think about troubleshooting collisions from a wireless design standpoint and making sure that you're using .11g, for example, that uses much more intelligent algorithms and modulation schemes. Make sure that you aren't oversubscribing that particular area with too many devices. You may have to also use tools. We'll talk about some of these tools in upcoming nuggets, but you may actually have shorts in your wires, okay? And that can happen when wires come loose or they break away from their shielding. Damage is done to the cable, it gets bent. You can have shorts, and that's going to completely break down the communication path or lead to data loss or loss of integrity. And so we've got some tools that we can use to actually help us find shorts in a wire. And we'll talk about some of those tools later on. But while we're here, I'll go ahead and mention that you can get network cable testers. Network cable tester, for example, from a company like Starin. There's many of them, but these will help you locate where that particular short is in the cable, so you can either repair the cable or replace the cable. Sometimes, because of the difficulty of getting access to cables and the cost of replacing it altogether, finding the short and repairing it at that particular point is a much cheaper and much more efficient option. And we've already talked about the interference issue. Again, this is going to relate to things like crosstalk. As we know, going from unshielded twisted pair to shielded twisted pair is going to help us with our interference. We know that coax is less susceptible. And then we know, of course, going to fiber optic cable is our best solution for mitigating against interference. You could also change the circumstances. You could try rerunning the cable so it's not going to be susceptible to EMI if it's run next to some machinery or some other mechanical EMI outputs. You could rerun the cable, or you could look at ways to better insulate that cable. Finally, we have the impedance mismatch. Impedance is the combination of resistance, inductance, and capacitance in a cable. It's measured in ohms, and it opposes the flow of the current. Impedance mismatch can cause problems. The best way to mitigate against this is what all good network engineers do. They purchase all of their cable together from the same vendor, the same type of cable, instead of having a hodgepodge or a mixture of different cable types. Be consistent. Another term that I just noticed that you need to know for the exam is called NEXT, N-E-X-T, and that is near-end crosstalk. Near-end crosstalk is going to happen because an alternating current flow produces an electromagnetic field around the cable, and then this field will induce a current flow in other adjacent cables. And the strength of this field is going to get bigger with the frequency of the signal because the speed of data transmissions is getting faster and faster. So next can also be a big problem if you aren't careful about the way that you're implementing your cable. Now, one other tip here. In cabling, for example, are UTP cabling, crosstalk is going to be at its highest level in the RJ45 connection as it nears the end of the cable. Okay, so near end crosstalk refers to that crosstalk that happens because it's most likely to occur near the end of the cable. So obviously the twists in the cable help to cancel out the next effects, and of course making sure that you're applying your RJ45 jacks and repairing those is extremely important. Next, we're going to move up the OSI model to data link layer 2 and network layer 3. We're going to look first of all here at port speed and duplex. Remember, the Ethernet ports, we'll just use Ethernet as our example, have port speeds and duplex, and those settings typically have to match between the end station and the hub or switch, between the server's network interface card. And remember, these ports, these switch ports, these network interface cards, they're a combination of a physical component, and there's also a software component called the device driver. And this device driver is a combination of files that basically works as an interface between that physical device and the underlying operating system, either the network operating system of a Windows environment, maybe my Vista operating system on my client, or the iOS on a Cisco router or Cisco switch. And so sometimes these port speeds and duplexes can be hard-coded, and if they don't match, you're not going to have connectivity. And sometimes end users will go and they'll just play around in their graphical interface. They have access to it, and they can cause problems. Let me give you an example here. I'm going to go ahead and open up this network connections. And this is my Vista machine. I can see my local area connection. And if I right click on it and choose properties, and by the way, you also have the ability to go and use diagnostic tools that are built into your devices as well. But I'm going to go to properties, and I'm going to notice that I'm using this Realtek whatever fast Ethernet NIC card, and you can see the MAC address is showing up as well. If I choose configure, I have some configuration information that I can use to troubleshoot. For example, I can go to this advanced area here, and you might want to check and make sure that things that should be disabled or auto-negotiated are configured properly. In other words, if the end user come in here and change, for example, the speed in duplex, which should be auto-negotiated on this particular device, whether it's connecting to a wireless access point or a DSL router or a switch, I should go ahead and have my speed and duplex be auto-negotiated. But you can see here the values can be changed to 10 megabit per second full duplex, 10 meg half duplex, 100 meg or fast Ethernet full, or fast Ethernet half duplex. And so you might want to check that out. The same thing can happen, of course, over on the switch. And in a second here, I'll take you over to my adaptive security appliance, which also serves as a switch and a router, and I'll show you how that can be configured there as well. But speed and duplex, those need to match. They need to match the network topology, the logical topology that you're dealing with. Okay, I'm back over on my adaptive security appliance, which has the features of a switch. You can see here it's got 4 Ethernet ports. It does VLANs. It does trunking. It's also got routing capabilities, of course, all these different dynamic routing protocols. But I want you to go over here and take a look at, for example, this Ethernet 0, which is on the inside, which most likely in most scenarios would connect to a switch or multi-layer switch. If I go to Edit, I can go and take a look at the properties here, and you want to make sure that the properties are what they should be. You choose the right media type, for example, RJ45. Duplex is auto configuring duplex and speed. So we want to make sure if both sides are using auto, that's great. Otherwise, you may have to hard code these for full and half duplex. Speed 100 megabit per second, 1000 megabit per second, and some interfaces would also be 1000 megabit per second or 1 gig per second. And of course, the only time you'd have to probably hard code the speed in duplex is if you were connecting 2 devices together for redundancy or fault tolerance. Sometimes the channel that you create between those 2 devices that sends maybe the state information and the communication that they connect to ping each other or send hello packets back and forth to make sure that the other one's still there, that the main active device is still alive. often you have to make sure that you have that hard-coded and not auto-configured. So again, several places in your network infrastructure to take a look at things like duplex, speed, and media type configuration. Also on the switch, and I'm not going to go and show you a switch configuration because it's just a brief thing, but configuring VLANs on switches are very simple. It's just simply a couple of commands in the command line interface, or if you're using a graphical management tool, it's basically just put in some input. You basically create a name for the VLAN, and then you assign ports to that VLAN. So you want to make sure that as you're placing ports, which represent end stations or servers or other network-enabled devices, if you're placing them into the VLAN, that you're doing it correctly based on your network topology. That's one of the most common areas of troubleshooting from a layer 2 standpoint, just misconfiguring the VLAN configuration on your switch. Also, if you have switches that are going to be trunked together or connected together, and that you're going to allow VLANs to cross those particular switch trunks, there are certain protocols, for example VTP, the VLAN trunking protocol, and this should really be called the trunking replication protocol, because it replicates data, trunking information and VLAN information from one switch to another. Misconfigurations in VTP can also cause problems. That's again one of those escalating issues that should go up to a network engineer, but realize incorrect VLANs are very popular troubleshooting issues. You also want to make sure that on the client side and any routing device that you've got the correct IP address configured, the right gateway, DNS, WIN servers. Let's take a look at that real quick. Let's go back to our network connections here under Settings, and I'll right-click again on my network connections, go to Properties, and we want to go ahead and choose our Internet Protocol version 4. Notice that by default Vista has IP version 6. I'm going to go ahead and choose this option, and again, you want to make sure that if this device is supposed to be a DHCP client, that you are indeed obtaining the IP address automatically. Okay? If you're using a statically configured IP address, you want to make sure that that IP address and subnet mask are configured properly. The default gateway is important because if this particular Vista workstation wants to send or receive traffic outside of its broadcast domain or its network or subnet or VLAN, I'm going to have some device, some routing device set as my default gateway. Now that default gateway address, and a lot of times it is the first available address in that particular subnetwork. A lot of network professionals will put the router or the server doing the router or the firewall as that first available address. So this default gateway needs to be the router interface, or maybe it's a Windows multi-homed server with RRAS on it that's doing the routing, or it could even be connected to a firewall if I want to go that way. I need to have the correct default gateway address in there, otherwise I'm not going to be able to communicate outside of my network. So I can still have connectivity with my other devices that are in my same broadcast domain or in the same VLAN. And I wouldn't even know I'm having problems until I tried to, for example, go to the internet and I can't get past the router to the internet. So the default gateway is important. Also, your DNS server. If you're getting that address automatically from DHCP and that's what you want, make sure it's configured properly. You can also statically configure the DNS server that you want. There's also advanced settings as well, where I can do DNS settings and advanced WIN settings. So if you're troubleshooting a Windows environment that uses NetBIOS, and it's still used, even in Windows Server 2008, network load balancing uses NetBIOS names, so it's not going away anytime soon. And you can see that also things like if LM host files are being used, these LM host files can cause issues with name to address mapping, because there are certain applications, there are certain tools that your end user could download from the internet that can actually corrupt that LM host file or add entries to that LM host file, and that could cause their browser, for example, to be redirected or to bring up other nefarious web pages. So these are just little things you might want to check out. Take a look at that LM host file. Okay, finally, we've got DHCP. I've mentioned that from the client end, but you would also remember that if you're the DHCP administrator, and again, this is not a Microsoft course, but it's quite likely that if you're not already, you're eventually going to be some type of network administrator. That may also mean administration of the domain, for example, in a Windows environment. So part of your responsibility may be to actually go up to the DHCP server and create those scopes of IP addresses, those range of subnets and prefixes that you're going to lease addresses to. And a lot of times that scope can be misconfigured. There's over about 250 different options that a DHCP server can assign to a client, and so some of those options that are configured. For example, you can tell the host what domain it's in. You can tell it its email server, its DNS server, its Win server. You can get all that information, and if you misconfigure that scope, then all of the clients in that scope are going to get the wrong information. And that's another thing to think about. If you have a bunch of end systems, and they're all DHCP clients, and they're all getting the wrong kind of misconfiguration information, then think about the DHCP server. That's the one thing that's common to all of those clients in the same scope. So logical issues. Now, one of our challenges with dealing with wireless issues is the fact that we're dealing with RF, which can be, this is a whole area of physics, and there's a lot to learn about RF, and we don't even understand how it works exactly as human beings. And so I'm introducing terminology here that you may not have the background for, but to make it simple, there's many different types of interference that your wireless laptops and your workstations and your handheld devices can deal with is to try to access this access point or wireless LAN controller. And absorption is one of those, okay? Absorption is heat, okay? And it's absorbing the waves. So you might want to say, what are some of the things in my environment, wireless environment, that can actually cause absorption? Well, it could be people, their bodies. The more people you have in an area, that can affect your wireless implementation. Walls. Sometimes walls are carpeted or they have special kinds of materials. Carpet can absorb signals. It's kind of like sound. You can soundproof a room by packing it full of, acoustical tiles and soundproofing tiles. Well, the same thing happens in a wireless environment. Another obstacle is reflection. Okay, reflection is going to occur when a signal bounces off of something and travels in a different direction, and that reflection can lead to this concept here, which is known as multipath. Okay, multipath occurs when part of the signals are reflected and then they arrive at the access point out of sync, so they get to a different order at the receiver. Now the receiver has mechanisms built into the .11 standards in the frames to deal with multipath, but it can cause the signal to become out of phase. And out of phase signals can cancel each other out, and that leads to a null signal. So that can also affect your network as well. And things like, planters and elevators and thick materials can cause reflection. Scattering occurs when a signal goes in many different directions. So it could be caused by an object that has reflective yet jagged edges, maybe a lot of dust particles in the air or water. Think about light shining into a pile of broken glass. Now, scattering is typically more of a problem when we're outdoors. But if you're working in an inside environment with your wireless and you have a lot of, let's say, fake plants all over the place, or balloons hanging down, or posters hanging down from the ceiling, that can cause a scattering effect as well. Refraction is the change of or the bending of a waveform, and typically refraction is going to happen in an outdoor wireless wide area network environment, or if you're bridging wireless between a couple of buildings. Water has a tendency to do refraction. So again, the point is there's several different types of interference. Some of these can cause multipath, some of these can cause loss of signal or signal degradation. So we've got refraction, we've got scattering, we've got multipath, we've got reflection, we've got absorption. Now, early on in the wireless nugget, we looked at configuring a wireless access point. So I'm not going to go back there again, but realize when I'm configuring my client, I need to make sure that I configure the right encryption type and the right encryption key. On my Vista machine, I can go to the Network and Sharing Center here, you can see here's my wireless network. Signal strength very good, and usually you have some type of tool built in. I have this Intel ProSet wireless tool. I think I'll run this. I can diagnose my wireless connection. Let's look at statistics here. Shows me general statistics, my AP MAC address, no name for my access point, it's unknown, nor do I know the IP version 4 address. I can see signal strength, noise level, how many beacons were received, transmit and receive information here, association and roaming. Got one association with an access point. They found 3 access points. I can also do some logging. We've already talked so much about the importance of logs. I could start logging now and log for a few seconds. I think it's going to sample every 5 seconds, and then we'll stop logging, and then we can view the log file. Here's the most recent one in the default location, and I can go in here and see this Intel ProSet wireless logging, date and timestamp, adapter information, connection information. Okay, so knowing things like the SSID is important. Okay, knowing what band you're using, what channel you're using. You can also scroll down and get other information that's RF related and really beyond the scope of this course, but a lot of good information that I can find, again, for just basic wireless client troubleshooting. So make sure you're using the right encryption type, whether you're using WEP or WEP pre-shared keys. Maybe you're using WPA, WPA2. Make sure that you have the encryption, because the policies have to match on the client and the access point. And of course, if you're having key configuration, make sure those keys are the right keys, the right password. Often you'll have to change your keys in the access point from time to time due to security policy. Make sure that the client side is configured as well. Now, you configure your access point for the channel that you want to be, for example, in the SSID. So this SSID or this area may be using channel 1, and this, of course, may be using channel 6 or channel 11. But as you saw earlier, I actually have my access point. Using channel 10. And it depends. I've got 3 wireless access points in my home, and so because of the channel management, we're going to choose different channels. And again, your host or your in-station will do auto scanning. It will scan for that open channel, but you may hard code that within your business as well. If you have 2 access points that are working together through a switch or directly connected so that users can roam and have mobility from one area to the other, you want to make sure that they're configured with the same SSID. So this extended service set, okay, has an ESSID, and those need to match between these access points. Am I using mismatched standards? For example, am I using 11B on my access point, but I've got 11G cards, or vice versa? Typically, you're going to be B and G. The mismatch typically comes into play when you've got an access point configured for .11a and you've got a BG card or antenna on your laptop or your handheld device. So make sure the standards match. There's also .11n to contend with now as well. You want to make sure that you got your distance, and you should go use a tool like ArrowPeak, which, well, you know what, I have that tool. Let me just show you real quick what I'm talking about. Let's see if I can find that puppy. Oh, here it is, ArrowPeak. I don't think I have an adapter that can work with this. I don't, but okay, I would need to use my other adapter, which is compatible. These tools only work with certain adapters, and the one that's built into my Vista machine isn't compatible with ArrowPeak. But this is the kind of tool you would use. It has all different types of monitoring and capturing tools. It's a packet sniffer like Ethereal or Wireshark. It's also got other IP tools as well built into it: ping, ping scan, trace route, name lookup, DNS, port scan, service scan, finger, whois, just a lot of great tools, monitoring tools as well. But I can do wireless packet sniffing. So you'll use this tool to do wireless analysis. You will go in and you will analyze the environment. You'll make sure that you have the right distances. You look for things like interference, multipath. You want to make sure that your RF doesn't extend too far outside of your building. so that people can come do war driving or war walking and get access to your network. You're also going to use AeroPeak and other tools to place your antennas in your organization. And antenna placement is a key aspect, because if you do not place them properly in the beginning, you will be doing a lot of wireless troubleshooting for those clients who are going to find dead spots or areas where the RF just simply doesn't connect. And again, if you configure your antennas and you have designed your wireless network, and then sometime within the next few months you rearrange the furniture or you do some type of drastic change to the internal topology or placement of desks and cubicles, that can have a dramatic effect. You'll have to come back in again and do wireless analysis again to reconfigure your antennas and reconfigure your network. Now, what this last topic talks about are the kinds of issues that, as a beginning network technician or beginning network professional, these are probably going to be for you what we call escalated issues. These will go to a higher tier of person in the service desk, probably somebody with years of experience in routing and switching. You'll also look at escalating these through trouble tickets, or finding people in the organization that are higher up that can deal with this. But you need to understand that as far as troubleshooting goes, and this goes back to the 9 steps I gave you in the previous nugget, there are instances when you're going to have to escalate the issue, when you can't solve the problem and you have to move up in the pecking order or in the organizational chart to get the problem solved. Some of these issues are going to be dealing with the way that your switch infrastructure or the matrix of your switch structure is designed. You've got a spanning tree protocol which layer 2 switches and layer 3 switches use to prevent loops with the frames. And so spanning tree protocol is very elaborate to design, and the more VLANs you have, for every VLAN you have an instance of spanning tree protocol for that VLAN. And so if you do not choose the correct root bridge, and again, basically the tree is just built from the root. It makes sense, doesn't it? The tree is built from the root, and it will automatically shut down ports to prevent loops. So if you don't choose the right root bridge for the VLAN, you're going to run into problems. So this is an escalated issue. Routing loops can occur, but they're a lot less likely to occur if you're using, let's say, RIP version 2. The IP header has a time to live field, and every time that packet crosses a router, that time to live field is decremented by 1. So it goes from 16 to 15 down to, when it gets to 1, it gets to a router with a TTL of 1. That means it's going to be sent to the bit bucket next, or that garbage dump of bits on that router. But routing loops can still occur, and there are certain attacks that can cause routing loops, especially with dynamic routing protocols like OSPF and EIGRP, which can allow for much greater time to live values. So if routing loops are affecting your bandwidth, that's going to be an escalated issue, because it's going to involve most likely a Juniper or an HP or a Cisco engineer to deal with that routing topology. Routing issues can be under your purview, because remember, we do have routing tables on our end user stations. My Vista machine, my XP machine, they both have routing tables, and you can configure default gateways and static routes in those routing tables. You also have routing issues within your network as well. Most routing issues are going to be dealing with things like an improper or misconfigured default gateway configuration, or you've misconfigured your dynamic routing protocol, RIP version 2, OSPF, EIGRP. You may also have routing issues at the perimeter of your network as you connect over your provider to your branch office. Again, these are advanced networking topics, but this could be an issue that has to be escalated to your network team. Broadcast storms can be caused by certain types of layer 2 attacks on switches. Proxy ARP should be disabled in your network. It can also cause problems, and especially in a wireless environment, the introduction of rogue DHCPs, or bringing in a DHCP server either on a laptop that connects to the network, the Ethernet, or a wireless rogue DHCP server. On my laptop right here, I can actually put in a network card and what's called a soft AP, and I can turn my laptop into an access point, and I can basically do a man-in-the-middle attack and become the DHCP server and then start redirecting. Let's say this is a wireless access point. I can start masquerading or faking out these wireless clients into thinking that I'm their DHCP server, I'm the access point they want to connect to, and I can redirect their traffic over to my soft AP. So rogue DHCP servers are also a big problem that need to be escalated up to the engineers. So you need to be aware not only of the things that you can handle, but that there are other issues that you must escalate up the chain to the network engineers. Having an understanding that some of those things can occur and that they are things to look out for will only help you as a networking professional. In this nugget on common troubleshooting issues, we talked about 4 main areas. Looked at physical issues, the most common issues as far as CompT is concerned at the physical layer. Looked at logical issues, layer 2 and layer 3 logical issues, wireless problems, and finally, things that may have to be escalated to higher tier technicians or to a service desk or to network engineers. I hope this CBT nugget has been informative for you. I want to thank you for viewing.